This video is about using the laws of exponents to simplify an expression. So below we have a table completed of our exponents. So we have 2 squared, which in the calculator we can hit 2 and the squared button to get 4. We have 2. This time there is no 1 power button, so we're going to hit the caret above the division button, 1, which gets us 2. 2 caret 0, which gets us 1. 2 to the negative first, 2 caret negative 1 gives us a decimal. So if we hit math, enter, enter, that gives us a fraction, 1/2. And 2 to the power of negative 2, if we hit math, enter, enter, that gives us 1/4. So you can pause the video and try them with the power of 3 to the n and finish completing the table. So what happens when a number has an exponent of 0? So notice that we have 2 examples of when we have an exponent of 0. We have 2 to the 0 power and 3 to the 0 power. Both answers result in 1. So when we have a number to the 0 exponent, the result is 1. So anytime something is 0 to the 0 power, it's going to be 1. And there's going to be special cases that we'll talk about in a couple seconds. What happens when the number has a negative exponent? So notice here, we have 2 to the negative 1, which is 1/2, and 2 to the positive 1 is 2. Those numbers are reciprocals because they're fractions and we're flipping the numerator and the denominator. So what happens when a number has a negative exponent? It turns to the reciprocal of the positive exponent. So let's use those properties today to look at negative exponents and 0 exponents. So first we're going to start with 0 exponents. So the general rule is that anything to the 0 power, a variable or a number, is going to equal 1. But we have to be careful because the 0 exponent is only going to go with what is directly next to it unless there is a parenthesis. So let's look at some examples with both a numeric value and a variable to see what happens when we have a 0 power. So when we have 2 to the 0 exponent is going with the 2, so this is going to be equal to 1. Same thing when we have 0, w to the 0 power, it's also going to equal 1. So it doesn't matter if it's a number or a variable, they're both going to equal 1. Now in the next one we have negative 2 to the 0 power. This is what we're talking about where the 0 exponent only applies to what's next to it. So since there's no parentheses, this 0 exponent only applies to the 2. So it's really negative 1 times 2 to the 0 power. Well, 2 to the 0 power is 1. So this is going to be equal to negative 1 because it's going to multiply with that negative sign that's there. When we have negative w to the 0 power, again, that 0 power is only going with the w. So this is going to be equal to negative 1. In the next one, we have parenthesis negative 2 to the 0 exponent. So this time, the 0 exponent goes to everything because of the parentheses. So this is going to be equal to 1. In the next one then, we have the parentheses of negative w to the 0 power. So again, that's going to be equal to 1 because that 0 exponent is applying to everything. And in the last example, we have just the number 2 in parentheses. So again, this is negative 1 because the 0 exponent does not apply to the negative. Same thing with the parentheses w to the 0, this is negative 1 because it doesn't apply to the negative out front. So there are some special cases to consider about what happens when there's numbers mixed in besides our variable with the 0 exponent. So here we have negative 3 x to the 0 power. So the exponent only applies to x to the 0, which is 1, but there's a negative 3 there. So it's really negative 3 times 1, which is negative 3. In the next one, we have 12 parenthesis negative 4y to the 0 power. So this exponent applies to everything in the parenthesis to make that 1, but there's still a 12 there. So we have 12 times 1, which is 12. Sometimes you even have enormous expressions. So with everything that's in the parenthesis, because there is a parenthesis here, this 0 exponent is applying to everything, so it's just equal to 1. In the second example, there's a negative 10 out there, so the 0 exponent is still applying to everything that's in the parentheses, which makes that equal to 1, so we have negative 10 times 1, which is negative 10. Now let's switch gears and let's look at negative exponents. So remember from the table before when we had 2x and 2 to the negative x, so if we have 2x squared and 2 to the negative 2, those are reciprocals of each other. So remember that they're reciprocals of each other. So when a number has a negative exponent in the numerator, it's going to move to the denominator of the fraction. And when a number has a negative exponent in the denominator, then it's going to move to the numerator of the fraction. So basically what's going to happen is it's going to move either from the top part of the fraction to the bottom part or vice versa, depending on where that negative exponent was located. So we need to make sure not to evaluate the number until it has a positive exponent, and we only want to move things that have the negative exponent with them. So when simplifying, we also want to remember to evaluate numerical bases that produce 4 digits or less. So we'll look at that as we continue with some examples. So in this one we have 2 to the negative third power, which we can put over 1 to make a fraction. Because this is a negative exponent, we're going to move it to the denominator of our fraction, so we have 1 over 2 to the third. Well, we can evaluate 2 to the third, 2 caret 3, which gets us 8, so this is now 1/8. Now, sometimes our exponents are also going to have variables in them, so we're still treating them the same way. It's a negative exponent here, so this 5 to the negative 4g is going to move up to the numerator, so it becomes 5 to the positive 4g, and we can put it over 1 if we want to, but when we move to the numerator, we don't have to put that 1 if nothing is left in the denominator. The next one, parentheses, negative j to the negative 6 exponent. Remember, when we are moving, we're only making exponents positive or negative. So the negative j is going to stay negative j, and it's going to move to the denominator. So we have parentheses negative j to the positive 6n. Nothing was left in the numerator, so we have to put a 1 so that we show it is a fraction in the denominator there. The next one we have x to the 5th, y to the negative 4th, and z to the 7th. The only negative exponent here is the y to the negative 4th, so that is the only thing that's going to move to the denominator. The x and the z are going to stay in their respective positions because they have positive exponents. So in the numerator, we're going to have x to the 5th, and in the denominator, we're going to have y to the 4th and z to the 7th. So in the next one, we have negative 4 k to the negative 8th. Remember that only negative exponents are moving, so k to the negative 8 is going to move into the denominator. Negative 4, because it doesn't have a negative exponent, gets to stay in the numerator. So we have negative 4 k to the 8th. In our next problem, we have parentheses negative 4 to the negative 5th, u to the 6th, and w to the 9th. The only negative exponent here is that parentheses negative 4, so we're going to move that into the denominator. So u to the 6th stays in the numerator, and then we have parentheses negative 4 to the 5th, w to the 9th. Now we can evaluate that negative 4. Because it's in parentheses, remember to put it in parentheses again, so parentheses negative 4 caret to the 5th power, which gets us negative 1024. So we're going to have u to the 6th and then negative 1024, w to the 9th. So it's a 4-digit number, so that's why we evaluate it instead of leaving it as an exponent. In the next one, 8m to the a, 3n to the negative 12b. So the only thing that has a negative exponent here is the n, so that's the only thing that's going to move. So we have 8m to the 9a. When this moves to the numerator, it becomes n to the 12b all over 3. Now 8 and 3 can't reduce, so we're going to leave our fraction as it is. In the next one, we have m to the negative third with a negative exponent that needs to move, and k with a negative exponent that needs to move. Everything else is going to stay in place. We have negative 6k squared over 10 m to the third z. Now, this time, negative 6 and 10 are divisible by 2, so we can reduce those numbers by dividing by 2, so we get negative 3k squared over 5 m to the third z. In the next one, when we look, we have a negative exponent. N to the negative second needs to move to the denominator. C to the negative 100th needs to move the denominator. And then parentheses, negative 3 to the 4th needs to move to the numerator, as does B to the negative 8th. So when I move my negative exponents around, I now have parentheses negative 3 to the 4th. I'm still going to leave that in parentheses. B to the 8th and A to the 4th, because that stayed in the numerator. And on the denominator, we have 9 squared, c to the 100th. 9 didn't start in parentheses, so we don't need to include parentheses when we move it. So now we can evaluate parentheses negative 3 to the 4th is 81, and 9 squared is also 81. So we get 81, b to the 8th, a to the 4th, all over 81, c to the 100th. Now 81, because it's in the numerator and denominator, those reduce to just 1, so we can rewrite this as just b to the 8th, a to the 4th, over c to the 100th. So let's look at a couple problems where we combine the negative and the zero exponents. So in number 1, we have a zero exponent of parentheses 9d to the 0. So that becomes 1, and we can rewrite this problem as a to the negative 12th, b to the 15th, all over c to the 15th. Then, because a has a negative exponent, it needs to move into the denominator. So we're left with b to the 15th over a to the 12th and c to the 15th. In number 2, we have this whole parenthesis to the power of 0, so that's going to become 1. So we have 2 times 1 times f to the negative 9th, g to the 3rd, h to the negative 12th. So because f and h have negative exponents, those need to move into the denominator. So 2 times 1 is 2, g to the 3rd stays in the numerator, and in the denominator we get f to the 9th and h to the 12th. So let's look at 2 more examples where we have to explain the error in complete sentences and then simplify. So in number 3, we have 2 m to the negative second equals 1 over 2m squared. So the error here is to remember that the negative exponent only applies to the m. So the only thing that should be moving is this m to the denominator, so our correct answer should be 2 over m squared. In number 4, we have 4 parentheses negative xyz to the 0 equals 1. So the error here is that this 0 exponent should only apply to the parentheses. So the 0 exponent only applies to the negative xyz that's in the parentheses. So this is really 4 times 1, which gets us a final answer of 4.